So blockchain developers, what do you need to know? Well, first thing, developing anything, right? What type of solution can I build on blockchain? That's always something that you want to figure out. What programming languages can I use? I heard a few questions on that asked here today. Can I reuse any of this code for another blockchain that I'm doing? Also, how do I build the dApp? Basically, is the bottom line here. You want to go ahead and build a distributed application that runs on a blockchain. And how about how do I verify smart contracts and audit? In other words, audits. Is there an easy way to do that that is really foolproof? So we'll take a look at all those during the course of the session. We're gonna the agenda here is getting started with Reach. Reach at a very high level. We're going to go in how you set up your development environment to build solutions. We're going to create a simple dApp for you and also talk about that verification piece. And then we got remote procedure calls, which is one of my favorite things. I think this facilitates multiple languages on the front end in building your dApp. So you can do things in Python, Go, C#, a lot of different choices there. Also, we're going to finish up, and JP is going to do some details in the inner workings of Reach, and we'll take it from there. And feel free to ask questions anytime. Put your hand up. We'd like to keep this as interactive as possible.
Yeah. So Reach is the safest way to build dApps on the blockchain. Currently, you've got to usually be in very low-level languages, Solidity or Teal as examples. If you make a mistake, you can lose all of your funds and all of your users' funds. Reach has a verification engine that runs at compile time. It runs with assert methods. It's very similar in syntax to JavaScript. And it also deploys, so Reach, you don't build smart contracts on Reach. You focus on the business logic and deploy to blockchains. And Reach builds the smart contract for you.
Yeah, and seeing how so many folks are new here to blockchain, I'm just going to show you this one slide here. And this is the Algorand blockchain, and basically the makeup of it. So it is an immutable distributed ledger, like we talked about earlier in the first session here today. And so it's basically read-only, and you just write once to it, right, with a bunch of transactions during a time interval. That time interval is a block, and so our blocks are burned in under 5 seconds on the Algorand blockchain. And belonging to a block, you have transactions then that belong to that particular period of time. Each transaction, of course, has accounts associated with it, right? You have to send from an account to an account for a transaction. And then each account also has assets and applications associated with it. Assets being your fungible and non-fungible tokens, and either creating them or opting into them. And then also applications are your smart contracts that you have, or dApps that you would be associated with that particular account. Also creating them and opting into them as well. So that's just a quick lay of the land and a quick level set for everybody to get on board with blockchain. Question?
Quick question. You're not like a sidechain or anything like that. You're literally your own blockchain.
We are our own blockchain. That's right. Yeah, we went mainnet about 2 years ago. Transactions under 5 seconds. We've got about 1,000 transactions per second throughput, and that's going up to probably 40,000 before it's all said and done. And transaction fees are very, very low. They're like a 20th of a penny. And that's a really big difference, like coming from Ethereum, where the price of gas is like outrageous for transactions. So we're getting a lot of growth in the Algorand blockchain community. So, and the developers are just coming out of the woodworks. Yeah.
One thing I will say that's, so I'm pretty much unbiased because I agree with blockchain agnostic. One of the things I love about Algorand the most is that they're the most real blockchain, meaning that they talk about what they currently can do and not what they can do. Mm-hmm. So everything that's you're going to see today is on production. It's there's been no slowdowns, no crashes for 2 years. It runs and it works today.
Yeah. Thank you very much, Chris. Appreciate that. All right, then programming language basically is involved with Reach. It's you have JavaScript, Python, more like we talked about for the front ends. Very high level language. Compiler compiles out to any blockchain. So this is very interesting. Right? One set of source code, and you can deploy it to Ethereum, you can deploy it to Complex, you can deploy it to Algorand. It really is
3 for 1.
Really is, yeah. It's really great. And then Deployment, like I said, it launches the appropriate node and you're off and running. And those are the blockchains like I just mentioned, more to come as well. So it has a front end and back end. So just typical, client server end-tier architecture, right? Separation of concerns is the main thing. So you interact between the front end and the back end, and you'll see some interact coding verbs once we get to the code
We'll
as well.
demo that today.
What's that?
We'll demo that.
Yeah, yeah. And Reach programmers don't need to think about the details, which is really nice. The contract storage, the protocol diagram, state validation, networks, and details. So you have the Reach architecture here in this diagram. So on the back end, on the right, you have the JavaScript-like Reach code. That's the server code. And it has the interfaces defined for the front end. Also, it has really the solution implementation, in other words, the contract that's going to be used. And then also you define who's involved, who are the participants, and this is where all the verification and commitment's done. Now on the front end, you got the user interface where you create accounts, do things like you actually have the meat of the interact methods up there. And any blockchain specific code might go there. So you might be doing a query, for example, to load a certain number of units of crypto. Well, if it's Ethereum, you might want to do one number, and if it's Algorand, you might want to do another number, that sort of thing. That type of logic would go in the front end. So you compile it, run it, and then boom, you're out to your blockchain. How does this compare to any Solidity developers out here? Show of hands. Few of you? Well, there's a number of tools, right, that you need to use to really go through the entire development cycle, right, when you're creating Solidity apps. The nice thing about Reach is the fact that it's all done with one tool. You got in Solidity, you've got protocol design, UML, you got smart contracts with implicit state space match protocol, middleware, uses SDK libraries like Web3.js, the front end that builds, they connect the wallet, MetaMask, user interface, and also you got testing and verification and deployment, right? All using different tools. With Reach, you got the protocol design that's done with the Reach programming language. You have the Reach compiler doing the smart contract. The middleware is the Reach API. The front end is built with JavaScript or RPC support for Python, Go, and more.
And we just added C#.
That's it, baby. I used to work for Microsoft. So I was really happy to see that one. I got C# in my blood.
Keeping it alive.
Yeah, that's it. And then also comparing Reach to Solidity development a little bit more. The testing, you got Reach Run, we're going to do that. Verification is done all within Reach, and deployment. So one tool. This is phenomenal. This is really a good breakthrough in the development of dApps.
That compiler is quick too.
Sure is. All right, let's take a look how easy it is to get going. So basically, you got to install Docker on your desktop. I use the desktop version of Docker, and that solves everything. So I've got that going. You do a copy down. You copy the research. The search executable, and that makes your Reach environment.
Yeah, it's just a curl command.
Yeah. So there it is, right there. So you just make a directory where you want the project, and then you curl it down, and boom. If you're running on Windows, there's one other step up front that's to set up your Windows subsystem.
With Windows, you run WSL2, which is basically Ubuntu on your Windows, and then you run everything through Ubuntu as an administrator.
Right. So we got links here in the deck, and I'll have a link to the deck at the end as well to get going in the different environments. There are some extensions in the IDE as well. There's if you go to VS Code, I'm going to use VS Code here. Show of hands. Good number of you. Okay, great. So look up the extensions. Just type in Algorand. You'll come up with extensions for Reach as well as for Algorand. All right. So once you get going, some of the commands that you use in the command line for using Reach, basically the two you use most are upgrade and update, and then you're off and running. And then run every time you want to go ahead and test it. There are environment variables you could set, for example, to say, okay, I want to run this for Algorand or I want to run it for ETH, and you just go ahead and set those up and you run it. Also, we have backend environment variables as well. A lot of times you need to have the token, the server, and the port number in order to do some coding with that. So those can be provided in environmental variables, as well as Indexer. Indexer is in Algorand. We have a great tool that basically is built to do queries, and very good queries, extensive queries. So instead of searching directly on the blockchain, there's a daemon, the Algo daemon, that will populate a PostgreSQL database, and then there it's a real database, so you can do really great queries with it. So that's the idea there with Indexer. Also, you've got backend variables as well with passphrase and nodes for the the faucet. You've got ETH node URI and network as well. Working with accounts, there's a lot of different account functions. A new account from a secret, right? From a passphrase. You have a new account from mnemonic. You've got new test account, create account. All these things run through accounts, and a few more here as well. Getting the address, for example, and connecting. Also, you've got if you want to get the balance of an account and do some transfers, there are also methods for that. Really a very interesting thing here in the project sample size, and and this just as you get this for free, right? With using Reach, you can see the actual number of lines of code that gets built to develop the entire DApp is a sample. This is just a sample, 450 lines, and in Solidity it was 813, and in Teal, which is the assembly language that Algorand uses, 2,177. So results vary.
Yeah, and that doesn't account for the stress of an undiscovered bug in your Solidity or Teal.
That's right. That's right. Okay, now we go to simple DApp walkthrough. So, anybody ever hear of the game Mora here? No? Okay. It's an ancient game, actually. It's a fingers game. You say me and JP are in a contest here, and you're ready to shoot some fingers?
Let's do it.
All right, 1, 2, 3, 4.
4.
1, 2, 3,
7.
All right, so you got to guess the total. He guessed it. He had 4 up. I had 3. So that's the idea. You shoot fingers and you guess simultaneously. This works great at parties. You have a line of people, and then the winner, has to pay for the beer or whatever at the end. That sort of thing. So this is a very cool game, and I know a lot of my relatives used to play it when I was a kid and everything. It's a lot of fun. So anyway, that's what we're going to demo here as this first demo in the application. Reach and Knit get you going. This is where you create your back end and front end, which is the Reach file and the JavaScript file. And then once you start getting in and building an application, what I like to do is just try to get the functionality done first, right? And just make sure the main, like the logic of the game, make sure the logic of the game, for example, works, right? In the first step. So here you can see, once we get going, you define the participants on the right. You've got Alice and Bob over there, and if you look up at the top, you can see that's where the interface is defined in the backend file for what it's going to be communicating with in the front end. So an interface is just a list of property and methods, right? So that's what you have there. You got fingers, guess, winning, and outcome, and they all take various parameters. You can see that we've got the guess is going to actually take an argument in, and it's going to be the fingers that you're shooting, because you want to add a random number to that, right? You don't want to guess anything less.
Yeah, at this point, this is pretty standard boilerplate.
Right. So Alice and Bob independently, throw the fingers, get the guess, and publish them. Over here, you can see down here, and commit means basically done. Now here's the logic of the game, right? So the match outcome, if they both guess equally, whether it's right or wrong, it's a draw, right? And then you go through it down every that. So this is actually the contract that you're building.
Right. So the biggest difference with programming in Reach is that you're focusing on how the participants interact with each other or with the contract. Mm-hmm. Whereas a full stack developer might be thinking about how the app will interact with APIs. But if you're a full stack developer, there shouldn't be anything like revolutionary about this. It's just you're focusing on business logic.
All right. All right, let's take a look at the front end here. Starting balance. So you got parse currency. In this case, it's going to be 10. I've got commented out example if you wanted to do one thing for Algo and another thing for somebody, another blockchain. So that would be on this standard lib connector, right? Is what you'd be testing the value for. Down below it here, you've got the starting balance. We're going to go ahead and get the starting balance from the account. And then down below here, this is where you have the contract gets initiated on the back end for Alice. And then Bob's going to go ahead and attach to that contract. So pretty straightforward in terms of what this is doing.
Yeah, we have a question in the back.
Yeah, question.
Yeah, I noticing some of the demos importing from the standard library.
Yeah.
Either imported straight from like NPM, like whether you want to do Algo or others, or it should just be set within the environment.
So this is a Reach standard library. We have a standard library that acts as an RPC, and that's so on your JavaScript, almost all of your programs will be importing from that standard library.
Right, and then this build folder here is actually, it gets created when you run it. And that's going to have all of the teal code and all of the ETH code in there as well. I'll show you that when we do the next demo. And then the front end also involves the interact methods that I talked about. So this is where you actually have the logic for getting the fingers that are thrown here. You can see it doing a random number here. I kept it simple here in the first demo to just do 3 fingers maximum, you know, that you throw out. So, and then you have to get the guess, and then you see the winning number. So building an app, the back end then extracts the implementation of the game or solution that you're building. You determine what is published to the blockchain and how. Also defines interfaces to the front end, as well as provides the verification. So all that goodness is done in the back end. The front end is going to be your interface, right? It could be use your prompts. I actually have a demo on showing you a React front end, you know, for a web-based solution to this as well, and then create accounts and interact methods as well. All right, so let's go ahead and do our demo here. So on the Reach init, I'm going to do here is just do a reach run, and then we'll take a look at the code. All right, let's span this up for now and just see this here.
Is this the Reach API IDE itself?
This is VS Code I'm running in. So I'm just running terminal in VS Code. And then you can see right there, okay, hello, Alice and Bob. So let's take a look at this. So when you do a Reach init, you're basically going to get these 2 files here. Let me bring them up. You're going to get this file is the front end, and this one's the back end. Let's take a look at the back end. So very, very simple, right? You got 2 participants, Alice and Bob. You deploy it, and on the front end, we're going to go ahead and parse out, you know, some currency, and then we're going to do a console log here for Alice and Bob, and then go ahead and attach to the back end. So this is all done very, very easily and quickly. If you take a look at this build library, when I ran that, this is what it looks like. And then if you scroll down a little bit, you can actually see that's the teal. And then I'll go all the way down to the next section. That's
This
the
is what Reach builds for you.
All right, so that was all done with that Reach run. All right, is what I did there. All right, so let's go ahead then and continue on with a little bit more of this game. And we'll come down over here. All right, so on the back end, okay, now we'll
There you
go ahead and do Reach run. So there we go. Alice shoots 0 fingers. Bob shoots 2 fingers. So that's a total of 2. Alice guessed 2. So Alice wins, right? And she's the winner of that game. So let's take a look at the logic that we have on the back end for that.
Real quick. They each shot 2 fingers, and the total is 2?
No, they didn't each shoot 2.
Oh,
Bob shoots 2. Alice shot 0.
Alice guessed 2.
Alice, I may have said that wrong. Alice guessed 2. Bob guessed 3. So Alice wins. All right, that's it. And then if we go ahead and take a look at what's in the code, we have the interface, right, for the front end with the finger methods, guess method, winning and outcome. This is the main guts, right, where it starts, the main program. And we're going to here go ahead and get the call the fingers on the front end, right, with the interact method. And then we're going to go ahead and publish those, right? We're going to publish them. And then Bob is going to go ahead and do the same thing. He's going to go ahead and do that, and then we're going to go ahead and publish those. And then the winning number is going to be the fingers of each, and then we're going to actually show that down below. And then here is the logic for the game. So by running this, it's, you know, a couple issues here at this point. One is Bob knows, you know, what Alice was publishing. So we're going to take care of that in the next demo. All right. And then also there's no loop here. It only runs one time. All right. We got to take care of that in the next demo as well. So stay tuned for those. All right, so then let's go ahead and move to the next slide, and then we'll come back to the more code. So let's talk about verification. So you got verification and audits, right? These protect against blockchain attacks. And, you know, the biggest thing is you don't want to leave money on the table, you know, and this is a problem, right? If you create in a smart contract and fund, say, an escrow account in the smart contract, and you're creating this escrow account on the fly, so the only place that has the secret key to this escrow account is where? In the smart contract. And then you exit the smart contract and you're supposed to dispense everything in that escrow to all the participants by the end of the contract. But if you have algos left over at the end, bam, that's a problem. That money is lost. You can never, ever get at it again. And these are some of the problems that have happened in the past, building smart contracts that aren't formally verified or audited by a professional auditor. So these are things that you really want to understand very, very, very good before you get going building a smart contract in any development environment, let alone the Reach. Reach is going to help you out tremendously on this area. So it facilitates, general blockchain properties like token linearity. Okay. So the way you do it is you write down every single assumption into the program. So you can see examples there, some asserts, right? It provides the verification attempts to falsify the assumptions. So the verification engine is going to go through all those asserts and build a test harness, right, to make sure that you're all done. And so it basically, it's real. Who here has done asserts in their code? Few of you have. If you haven't, basically it's very, very simple. You just put in, for example, an erroneous state where the variable y is assigned to the value of 41. You do an assert where y is not equal to 41. All right, so that's the type of very simple logic you need throughout your application. Now, auditing, basically with a non-reach solution, an auditor comes in to approve the program, with their own analysis, right? So they're doing a verification of a version of the program. So what happens when you do a minor change? Well, the audit is useless now on the prior version. You got to come in and, re-audit the whole thing. So with a reach
Those aren't
solution,
cheap, are they?
What's that?
Those audits aren't cheap.
Yeah, exactly, yeah. And so the reach solution, the compiler verifies it. The auditor verifies if you provided reach, the compiler, enough assertions. All right, it's a little bit simpler, right, on that end of it. And also, code changes, the reach auditor just needs to check the right assertions were included for the code changes. So it really simplifies matters quite a bit in really verifying your DApp. So mathematical proofs are involved, runtime checks as well as compile time on mathematical proofs. Verification show that no flaw exists and no attack is possible. Reach provides automatic verifications to ensure it guarantees that your application are free from the entire categories of errors. So what does it ensure against? Things like losing funds, things like locking away funds, things like overspending funds. These are all no longer an issue.
Even including the ETH gas fees to make it happen?
Yeah, I mean, the ETH gas fees are all part of the equation, right?
They are. Yeah.
I haven't done much with ETH myself, but okay, so.
Yeah, they're
right.
part of the equation.
All right. So cryptographic commitment schemes. This gets into where Alice was publishing information that Bob can have an unfair advantage of seeing in this game. And so the way you get around is you apply a salt value and you make a commitment. And now it is now encrypted, right, for values that are getting written out to the blockchain. So you publish those salted values out. All right, you can see the salt value right there and make the commitment. And then also it facilitates the algorithm. It guarantees exploits do not happen by doing that. So use the make commitment and then check commitment to go ahead and declassify those and get those back to their original state. So the other thing you want to be very, very aware of are timeouts. It's not like you're building a web application where a user goes to a web application, then the next day they come back to the same place they're at and they can just continue. this is time. There's time problems here, right? So if you have a smart contract that goes and you wager, for example, we're going to do a little wagering in this game of more, which is more realistic. At least in my family, it was. You have a wager. Then what you want to see is, okay, we're both going to put 5 algos up in the wager, or maybe Alice puts 5 up, but she doesn't hear back from Bob. Well, you don't want those 5 algos to get locked away and the contract to die out. So you give a certain amount of time, and then Alice is going to get her 5 algos back if haven't met that match. So very, very smart. I'm really impressed with the engineers in 2 companies. To be fair, I'm going to be with Reach and Algorand. Really top-notch engineering staffs and really some
Force
good
your participants to be honest.
I mean, genius caliber. I mean, it's unbelievable working with these folks.
Otherwise, Bob has the advantage of a potential salt attack to go ahead and figure out what Alice says. Because
Right.
he gets unlimited time, and he has a history of previous salt. He gets an idea.
Oh, that's right. That's another good point too. Yeah, he said,
Salt attack to guess what she's guessing, and if money's on the line, that's exactly what I do.
Yep.
Make the contract take longer, and then hack through it that way.
yep.
Right. Yeah, humans will be humans, so we force the participants to be honest.
And so, yeah, the timeouts are important to consider, right, when you're doing this. And you can see here, there's various. We just added new various time elements. So absolute time, relative time, a few other things as well.
Right, you
for
can
your
measure
deadline.
time in standards of time or in blocks, the passage of blocks.
Okay.
Yeah, question here.
How is that timeout actually being executed? Is it the blockchain itself that's running that code, or is there an oracle that's calling a function after that time?
It's all done in the smart contract, right? It's going to go ahead and generate the code that says, okay, this is only, it's going to say, oh, it's only going to be valid for this X number of rounds, and it's going to check that in the code.
Does it actually run that callback when the timeout occurs, or is it going to run that?
Yeah, the internal, I'm not 100% in the internal mechanism, but I'm assuming that's what would happen. It'll go
Right,
to the
yeah,
callback.
So you can set the timeout to be for a certain number of blocks, and then per the consensus network
You'll
that
get the
you're-
callback.
that you're
Yep.
operating on. Yep.
Well, the question is that actually has to execute effectively in the miner, right? The guy who's executing the code, which
Yeah,
machine?
that's the question.
That's the question he's asking. That should be on the miner's machine fundamentally, because these are the guys mining the blocks. Once Alice triggers the event to start, that code's actually running. The timeout will affect that machine, and once that machine times out, if consensus is that it timed out, then it timed out.
Yeah, we're
That's the
talking-
thing. We're not worrying about that because that's kind of hidden.
Exactly right. And we're talking, this is all server-side code, right? This is all server
Yeah.
we're running here. So that we can do that. And by the way, there are no miners in Algorand. There's
Yeah,
no,
but it's a good way to-
I know, yeah.
Partition
Block
both
generators yeah, that's good. So, but anyway, yeah, it's very green. Algorand's very, very green. In fact, we're pledging to go carbon negative, I think. So it's really, you can run a node on a Raspberry Pi. I mean, that's how efficient it is. So. All right, platform-specific code. That kind of showed this already in the code where we commented it out before. But basically, you just check the standard connector on the STD lib, and it tells you what is actually being executed. And this is on the front end, right? So
Does
this is
the
going
at
to be.
mean standard for you guys, or does the at sign why at?
Yeah, so you can set it to be the latest, or you can establish a certain version.
Got it.
Yep.
Thank you.
Yeah.
So the flow on the back end could be a number of different areas or ways to do it. You have publish. You saw us use that, or pay, right? That you got one person involved, you're going to publish some information out to the blockchain, or you're going to do a payment transaction. You also have more complicated things for loops and doing each person. For example, you could have, okay, Alice, I'm going to do my guess first. Bob, okay, now I'm going to do Bob's guess. So each of them are doing it. Many, you can have multiple doing it, and also you have forks and parallel reduce and racing, which are really involved with a lot of looping kind of constructs. All right, so let's demo this. We got verification timeouts, make and check commits in the next version here.
See, and I will check out more of 3 with these applied.
Let's do a reach run. And then we'll take a look at this output. So A few things to notice here when this starts going. It's going to now spit out a bunch until it has a winner, right? So we got a loop going on in there. I did some debugging. I've got a print statement in the back end that prints out some values. Also, I've got the final total here. You can see this last one, she shot one finger, he shot 0, and Alice guessed 1, so she won. And we got some betting going on. We had a wager. I think Bob accepts a wager up here. And at the end, we're going to have a payment from one to the other right on the wager. So pretty cool. And then let's take a look at the code that we got over here. So if I come up to the top of the back end, let me get the right code up here.
You get an idea of how small those gas fees are on Algorand as well.
Okay, so we have back end first. All right, so here we have the logic, and we got some guesses, right? And then now we start doing some asserts. And we have these asserts are going to say, okay, different combinations, so-and-so is going to win. You know, if they both guess the same, it's going to be a draw. And then you want to do some loops through everything. So we want to pass all of these values into the winner method that we have and loop through every guess and every, you know, finger combination, right? And then we also want to make sure that like a winner comes out of that eventually is what we're trying to prove there. And then also you're going to check for a draw, right? Certain situations is always going to be a draw, so we put that in there. So that is for the assert part of it. And in fact, if I just go down here, I'll just show you how this works. I'm going to I'll go back to the code, but I'm going to change this transfer at the very end. I'm going to change that to just instead of transferring both bets to the winner, we're only going to transfer one, which is going to leave one of those bets on the table, right? So now if I go ahead and run this, again, you're going to see that this thing fails. And I'll tell you why in here too. It's going to come right up here and going to say, okay, balance 0 at exit application. That failed. That assert failed. You still got money left on the table. So this you know right away you got a problem. Which is just a real good safety net as a developer developing. You have to really, you know, when I worked for Microsoft, this was actually right after like 2001, 2002, we just started doing developer security seminars. And we really made the onus upon the developer, listen, you've really got to pay attention to how you're building code. It's got to be secure code. It's up to really you to develop these applications that are bulletproof. And, you know, then I started showing bugs, right, that common bugs that people would do. And that's the first time people ever started walking out of my sessions because they had to go fix those bugs that I already showed them right away, you know. So it was pretty cool. So this is very, very important, especially for blockchain developers writing secure code. And this really helps you do that. So let's go back and change that and continue on.
If you commented out a bunch of your assertions, would it identify that you don't have enough assertions to get through?
It's based on the assertions, is my understanding. So the better you do on the assertions, the better verification is going to be done. And an auditor would be able to assist with that, you know. Yep. So they're going to be able to determine, you know.
Well, I get that the auditor
Yeah.
But I was wondering if the tool Reach itself can detect that, hey, there's just, not that there's no asserts, but there's not enough asserts.
So the verification engine automatically runs 4 theorems,
Okay.
I believe.
For maths.
Yep. So even without any asserts, you'll get at least 4 theorems.
Okay.
Yeah, the mathematical theorems are in there.
Yeah, if you put no assertions in, it automatically guarantees against creating tokens out of thin air. Can you accidentally lock tokens in? I'm sure you've heard these issues happen before, so it automatically prevents against that. Math, it also for overruns, things of that sort, it guarantees that can't happen. That being said, in our roadmap, we're going to have a VeriSign-like functionality, where right now the assertions is very binary, off or on, works or doesn't. Because we will build an enterprise version of this that will analyze and give you warnings that says, hey, we analyzed your code, this is a pattern that we've seen before, did you make sure that you did the right thing? So that is coming in our enterprise versions, but it's not there yet.
Okay. All right, thanks. All right, great. And here's the interface. We got the player, generic player, right? They're all going to have ability to do the fingers, guessing, winning, see the outcome, and then inform a timeout. And then you have specific functions per player, right? So Alice is going to inherit everything player's got, plus we're going to do a wager and end. This was the logging feature I talked about. And then also you have a player right here, again for Bob, and he's got to have a method for accepting the wager, all right? And then this is going to be our deadline. We're going to go ahead and pass that in. And then also you have the participants in here as well. So first part is the wager. So Alice is going to publish that wager. Bob is going to go ahead and accept that wager. And then again, it's relative to the timeout that you have right there. And you can see what happens if it fails, and it's going to close out to A. And we're done, right? So that's how that works. And then you have a while loop now. So it'll go to there's a winner. And also you see the interaction
We got
there.
one question. Yeah, go ahead.
Yeah, your commit call there,
Yeah,
are you running some kind of emulator for the blockchain?
no emulator.
Is
This is,
that actually calling, is that calling out to the real blockchain?
yeah, it's actually going to be committing and publishing to the blockchain.
So, I mean, we're doing DevNet. So this is a test net here.
Yeah, there's different networks, right? So we got a playground here is what we're doing. So it's going out to like a sandbox type area. And then you have the ability to go to testnet, mainnet as well through settings as well.
So, and that commit just abstracts the fact that that's going to be a commit on whatever network you publish, right?
That's right.
Right.
Right. So then we get into doing the salted values like we talked about, and then we're going to go ahead and make those unknowable to Bob. And then down over here you've got Bob going to make his guesses, and then what's going to happen then is we're going to declassify those and unsalt those values and publish the actual fingers now that Alice had to the chain. All right. So then we've got the rest is adding the numbers together and then seeing the winning number. So let's take a look at the front end. So the front end here, this is where we're going to instantiate the library course like we saw before. And we're going to go ahead and get going with creating a new test account. And then we have basically the balance we're going to go ahead and display before we run the application. And then also this is where we put in the logic now to do all the math for the random numbers. We also put a little bit of an occasional timeout in here, a loop, a random timeout thing to test that out. And then also you have ability to get the guess down here, and then the other ones are just prints, right, that come down over here. And then there's the wager that gets placed right there for Alice.
And he can't, and it's set up so he can't accept the wager if he doesn't have enough to back the wager.
That would be true. That would have to be checked if he's got enough to do that. So in the beginning there, we're deploying enough to both to be able to do that in this example. All right, so let's try to do this.
Your real dApps would interact with the wallet, so MetaMask or ARC0011.
And when you say front end, back end, that's effectively what you're talking about, is whether or not you're interacting with MetaMask or you're interacting with the back end, the miners.
Right. So the front end stuff would do all the interacting with MetaMask or with AlgoSign here is the equivalent to MetaMask in the Algorand world, and there's other wallets. And we're actually we have a standard now for wallet interfacing to our ARC3 standard. So that's all coming along. It's really coming out pretty good. What's your name, by the way?
Kirk is in
Kirk. Captain. We got the captain with us here, front and center. This is great. Yeah, this is great. All right, so that's the output, which I already showed you. So let's go back over to the deck. All right, RPC, one of my favorite sections of this demo, right? And so we got the ability now to build front ends in Python, Go, C#, and JavaScript. You've got RPC client standard options that you would put and actually pass into your host, into your application. So what you do is create a dictionary object, you do the call to instantiate, and you have options to set up a host, a port number, timeout values, that sort of thing, rather than using environment variables, because now you're not on the server anymore, right? You're out somewhere else. And so now you have the ability to build those right into on the client side. Everything we're talking about now for RPC is front end. All right, so The same reach file, RSA file, is used in every one of these examples I'm about to show you. That hasn't changed at all. Just the front end is going to be different, all right? Now, so what we do, and again, I got this more for reference for you than anything. When you, for Python, you go ahead and create your virtual environment. That's the command to do the install, and then you just run it with the reach RPC run this time instead of reach run, and you specify the name of the file. And then for JavaScript, same thing. You've got some install instructions there for npm, and then you have the run it, which is by RPC run node, and then the file. With Go, there's a language to download the RPC for Go, and then you do an RPC run with Go. Deploying the Algorand testnet, someone had some questions about that. These are some of the environment variables that you would need to do that with. So you got to set up your ports, your servers, that sort of thing, and also timeout values. Then you got, this is what the code looks like and how it's different. So what I've been showing you up till now is on the top box using JavaScript locally, right? Server and front end are together. So that just instantiates stdlib, and then it's stdlib dot. For RPC, what you're going to be doing is you're going to basically using callbacks, right, to make this whole thing work. So you're going to go ahead and then send endpoints in to stdlib / parse currency, right? So that's really the difference. Is you're just going to be using endpoints rather than the actual library locally. And same thing for Python, same thing for Go. So let's do a demo here. Now we're down to CD Mora 3. All right, so let's go ahead and do this. So with Python, all right, so we're going to go ahead and create our front-end virtual environment. All right, so that's done, and then now we're going to go ahead and install the client. And then the last thing we're going to do here is we're going to run it. So here we go, it's running now in RPC mode, right? And so let's take a look at what changed on the front end now. So let's go ahead and bring up the code for Python. I'm telling you, of course, I came into Algorand, I just love C#, and we actually got a lot of support now for C#. The community really came through with the .NET SDK and everything, and but it's Python. I write all the demos, a lot of demos, and I do them in all 4 languages that we support at Algorand: Python and Java, JavaScript, and Go. Python wins every time in the least amount of code to accomplish a particular task. It's just amazing. So I've come around, to that. All right, so here we go. We basically have, I've got a comment out here, but this is options that you could set up like I talked about in the host environment, and then you just feed that dictionary in when you invoke the RPC package, okay? I'm going to just call that, and then here now you can see all the calls change now from before to this stdlib, / method. So, and everything that's done, any stdlib call basically is what you need to change. So everything else looks pretty much similar.
And it's all in our documentation.
Yeah, that's good. All right, I want to go show you one more demo here in the next section as well. And this is using React, and this is also using, this is going to be using pipeline controls. And with the React front end, we're going to go ahead and show you this, and it's really incredible. Pipeline is a third party partner of ours. It's like Reaches, and they actually built a set of controls that are Algorand centric. So for example, if you want to, let me just go out here. If you go out and try their components, like a Algorand address, this will be like a pop-up. That stuff's built right in, right, with the QR code and the address that you can copy from. So this is going to save a lot of time for developers doing web-based solutions on the Algorand platform, as well as a lot of great controls that they have available that you can use in all the components, right? All the, the box, the button, all that kind of stuff, that's all in there. So anyway, I want to give them a shout out. They helped me actually build this next demo we're going to take a look at. And so now this should be firing up, and there's the game coming up. So now we'll go ahead and deploy it. and now you're going to see the same emulation that we saw before over here on the right. This is a pretty cool thing, and they also have controls that are just JavaScript based as well. You don't need to use the React framework. Yeah. So and there it is. So there's the whole game. It runs there, and this is pretty cool. Pretty cool stuff. So now you've seen full swing here, right from getting started all the way through creating a web interface, and all these code samples are available. I have links in the deck to all these as well. All right, and there you can see the code. We're going to wire up the servers, the ports. And then this is the same code that we saw before on the front end. And in here, in this case, they're deploying the back end with it, but I could see enhancing this app to use RPC, right? It would be more of an appropriate structure, I feel. But it works. So right now, that's good for demo purposes. Okay.
Yeah, so you've seen a command line interface and an actual UI.
All right, and we have some resources for you, and then we're going to have JP run through some slides here on internals. So the Reach Developer Office Hours every Friday. Join the Discord channel. We got a link coming up on that from 2 to 3:30. Is that like a happy hour flavor on Friday afternoons? Is that what you do?
Friday
that?
afternoons, hop on, talk to us, ask questions. We have a global team. There's always someone on in the Discord, whatever time of the day or night you like to develop. Yeah.
Cool. And at Algorand, we run our office hours on Tuesdays, every other Tuesday, typically around noon. A lot of great content out there. I've done a few sessions on Reach as well. We get a lot of people in from the community to do talks, and then we save some time also for just general questions in general that folks have and developers have. This is a really nice hackathon, bringing everybody's attention to. It runs to the middle of January. You got plenty of time, over $100,000 worth of prizes there. So it's at the Innovate under the Hacker Earth site.
Yeah, grab that QR code.
Yep, there you go.
It's in the slides, right?
It's in the slides.
It's in the slides too.
And then also the resources here. So Algorand Discord up on top. The Reach Discord. I highly encourage you. Anybody here using Discord? A few of you? Okay, most of you. That's
Good
great.
majority.
Yeah, I'm bored. Okay. So we got over 20,000 developers now in the Algorand Discord.
That's amazing.
You guys are growing too.
We are growing.
Yeah,
I think it's 30% every week.
it's great. New folks go there, they get their questions asked, and then they start learning more, and then they start contributing. And other people ask, and that's how it works. It's a community kind of environment. And then we also have the developer portals, right? And you got these are the Discord links. I'm going to show you this real quick. This is the developer site. You've got really great stuff on it. We won an award for this portal. I think Developer Weeks gave us a Debbie's Award for it. You've got the smart contract section right there, and also building in PyTeal, which is the Python flavor of Teal. And then you have tokenization, integration on all the SDKs down there. Under Docs, you see a lot of getting started. What is a blockchain, tokenization, integration, get details. You can go drill right down. Also, under the blog section, we've got tutorials, solutions, articles, tools, a lot of great tools. This is our ecosystem out there, a lot of IDEs. You've got a lot more SDKs, wallets, Signer you saw there, Argo Signer, API services. There's all the SDKs that are in the ecosystem. .NET SDK, Dart, PHP, Rust. And we have a lot of samples of this in tutorials on our site. The newest kid on the block, and I can't wait to try this, is the Unity Algorand SDK using C#, right? So I'm really looking forward to. In fact, I've got to review a tutorial on that on Monday when I get back to the office, and that's going to be when I'm using there. So we talked a lot of things. We've had Reach at a very high level. We set up development environments. We did show you step by step on creating a sample dApp, and then also verification process, and then the really flexible front ends now in multiple languages with RPC. And then we're going to go ahead and turn this over, and I can be your PowerPoint maestro here,
Right
okay? Okay, inner workings.
Yeah, so the inner workings of Reach in 15 illustrations. So this is more of a deeper dive. You've seen it run, you've seen the examples. So this is explaining like how we build it, and then how we use Reach to produce dApps and interact with a consensus network. So again, it's a programming language that helps developers focus on business logic of the dApp, and we take care of verification for you. We do the compiling. You don't build a smart contract. You're preparing business logic. All right, so we focus on participants. As I mentioned before, most full stack developers, you're focused on how your app will interact with APIs. You're very API centric. With Reach, the mindset is shifted a bit to the participants, to your users. And I think that intuitively makes sense. You should be focused on the people who are actually using your products and your services. And so what this does is you think about the participants, how they interact with each other, and how they will interact with the consensus network. So as a developer, you start by creating the backend, the index.rsh file. And this is where all the backend logic lives. When you create an interact object, you have a participant backend, so you have a participant interact interface, which is the interface where your participants will interact. You have objects, they look very much like JavaScript objects, and then we'll compile that into index.main.mjs, which we briefly showed you earlier. This mirrors it, so it will compile, it will hold the interact objects. The compiler keeps that participant backend, and it's all in that build. So this also allows you to interact with the consensus network of your choice, right? Your blockchain, Algorand, Conflux, or Ethereum at this point in time, and we're continually growing, okay? And so this compiles the bytecode, which is what we see here. This bytecode contains the ABI and other information, essentially the smart contract. So we are creating that for you. And this is just showing that it's validated, so using those assert methods, we validate that the contract is secure. And then we come to the front end. So as Russ just demonstrated, you can use JavaScript, Python, Go. We just added C# functionality. And then if you have your own language that you like to use, you can boot up your own standard library and use that with Reach. This mirrors, so what you're seeing is the mirror effect. So it was like if you're looking at a perfect still lake and you have that mirror image.
Right.
So the front end mirrors the interact objects in the back end, and the participant front end matches the back end. So he went through his code samples pretty quickly, but the methods in the back end match the methods in the front end. And so what we have here is our standard library, which was asked about earlier. You're importing that standard library, and the library includes the accounts, address, and the contracts. Accounts and addresses are essentially interchangeable. Every account has an address. The contract is a little more involved. Contracts store values, it stores the consensus state, they receive and process publications, and modify the consensus state, and they make publications as needed, and then they can also pay, i.e. networks and non-network tokens. Right, so the dApp needs a wallet to connect, and we connect with MetaMask. So if you're running Ethereum, you'd be connecting with MetaMask. On Conflux, it's the Conflux portal, and then Algorand uses the ARC protocol. And then the dApp deploys the smart contract to the consensus network, and then now that network of your choice includes your dApp is on the blockchain now. And then participants are able to attach to that. They're able to interact. Interact shows the information. You're able to publish that information and pay. In other words, just like we interact with apps today, your participants can interact with these dApps. And so our goal is that you don't even have to think about the blockchain. That your participants don't have to think, oh, this is a blockchain dApp, this is a centralized application. You know, no one thinks about those things with like central apps. You're just using Facebook. You don't think about like Mark Zuckerberg, or at least your average user, right? And we want it to be the same way for your users when they're running your decentralized apps.
All right, man.
Right on.
Give it up for him. Yeah, man. Woo-hoo. All right, so this
All
is,
right.
you probably want to take a picture of this one too, because this is a simple NFT auction app. And so what we're going to do is I'm going to go ahead and go out to that site, and let's go ahead and clone this. And I've got GitHub Desktop, so I'm going to go ahead and do that, or you can just issue a git clone command, and then we'll go ahead and pull this out, and we'll open this up in Visual Studio. All right, so that's step one. And then we want to go ahead and bring up our terminal session. And then we want to do our install of Reach in that particular folder. So
Right.
let's take a look at what's in here, right?
And that's just a curl command is what you're installing.
Yeah, and you have the front end and the back end here, all right? And then what we want to do is go ahead and use that command to go ahead and install Reach to this folder now. Now you can see Reach is right there. It came down, so that's the executable. And then you want to just go ahead and run this, and then we'll take a look at the code.
And you see that installed in less than a second. It's extremely fast.
And now it's generating the build file.
So
And there it is, actually running the auction, where you got bidding going on back and forth, and you have a lot of activity between multiple participants, bidding away.
And above that, you can actually see the compiler is checking the theorems. It lets you know all the theorems. It checks when one party is honest, when all parties are honest, and it'll show you how many theorems it's running each time it compiles.
So this README file, we beefed it up a little bit just for you all here. So we got a lot of good links on the Reach documentation, as well as how to install Reach. You got to do Docker first, and then there's the instructions to go ahead and create that. And then here's the clone of this particular application. And then this is what I just demonstrated here, creating Reach. And then you can run a Reach version as well. It tells you what version. A lot of times that'll bring down the necessary executables as well.
The first time you run it will.
Yeah, and then if you do Reach hatches, it'll give you a bunch of codes, and these should all be the same. And if they're not the same, you want to do like an update or an upgrade to make sure you got it. And you can also verify if it's the latest. There's a releases channel in the Discord server for Reach.
And there's a link to that on the very bottom. You see that link to
Okay.
the Reach Discord server.
And then this is running it for Algorand, and then really just gives you an application overview. So let's start talking about that. So we ran it. So here's some of the basic functions. You want to go ahead and talk about what's going on here?
Yeah. So here this is pretty standard here. So we're looking at Reach. We're pulling in the Reach version, and then we're bringing in some constants. We have a maybe unit, which a maybe is a type in Reach that can be some or none. We have a show outcome constant and our parameters, and then we're creating this participant interact interface. And so this is in the Reach app, which is pretty standard for any kind of Reach application. And usually the first thing you're creating is that participant interact interface. And that's what you have here, the const creator and the const bidder. And so these are methods that the creator can use and that the bidders can use.
Okay. And then we publish the information. These are two example commands, right? The publish and the pay command. You'll see these actually down here.
And so when to the consensus network, when the contract needs to interact with the consensus network, it's either publishing or paying.
And then we get down to the consensus network code.
Okay, and so here we have the consensus network where we're showing that we're getting the constants of the highest bidder, the last price, and the current price. We're making sure that the current price is more than the last price. And then if it is, we're saying what to do. Okay, so if it is, update the current price and then return the bids. Here's your timeout function. So we've discussed this, but here's just an example of the timeout function where the creator sets how many blocks. In this case, we're running how many blocks. And if that times out, then a message is published.
Right, so that goes right after this. And then down here,
And this is your transfer. So the whole goal of the auction is that someone gets an NFT or the creator can cancel before the time runs out. And so this is where we have the transfer, where the creator is seeing the highest price and then showing the outcome to the creators and the bidders. Who's getting the NFT and who's getting Yes.
So since this is great, I wrote bidding software years ago, and so I have a question for you. We introduced an anti-sniping feature. So if you bid in the last 5 seconds, what we would do is automatically extend the auction 30 seconds. You could actually implement that using this kind of
You could.
algorithm for the timeout thing.
You could,
Yeah.
you could
Nice.
update that.
Nice, because that's when you make your most profit. Is the
Right.
seller,
That's right.
right?
That's
Right.
right.
So,
Yeah.
oh yeah.
Oh yeah, wait a minute. Let's go a little bit more. See if we get some more money. Yeah.
Right.
All right, now we're to the front end.
And so here's the front end. And so, we're kind of running through this fairly quickly, but you'll see some of the same method names. And so here we're importing the standard library, and then we're importing the compiled file as backend.
Right, and we got the creator, and then these are the participants, right, in the auction. Alice, Bob,
So
and
for here,
Carla.
we've got, three bidders in this case that we've hard-coded.
And there's a.
Okay, and then these are the interact methods. So this is where we're showing the balance. We're getting the balances of the NFT, which should be 1 or 0. And then we're getting the balance of the bids.
And by the way, this is the line of code right here that creates the NFT, right there. So we're creating an NFT. So it shows you how to
Beat
create
NFT.
an asset right there. All right, and then there's the back-end creator logic.
And so this is showing the bids, and then we're seeing the council messages, and this is for your command interface.
So you guys set this up for 3, but if this was a real bidding thing, this could be running inside of the wallet. You could see this as an NFT you're bidding on. You could
Yes.
see the bidding messages coming by, hit your own paddle bid button to
Yes.
bid against it, all in the GUI. And
Yes.
then when it closes out, it'll announce, hey, so-and-so's the winner, not by name, potentially by block or whatever, and transfer
Yep.
the asset, and then everyone knows that it was fair. But
Exactly.
right now, you just hard-coded the 3.
This is all
just
hard-coded.
for
They're
testing.
automatically bidding.
Right.
Right.
Of course. All right, good.
But yeah,
Got it.
in the real theme, we could all be here, or we could all be spread across the globe.
We got bidders in here, right, doing their job. And then we talk about verification down here, as well as remote procedure calls. And those are to be added, but we wanted to keep this simple for you, just to kind of understand the basic concepts.
Yeah, so you can grab that demo from, it's on the GitHub, on that QR code there.
Yep.
You can grab it, pull it, see. So a great way to learn that is just to make a small change. Maybe add another participant or take away a participant, and then see how that affects everything else.
Yeah.
And that'll help you get started on Reach. And then we do have documentation on Reach, docs.reach.sh.
We have Gitcoin bounties. So if you got the Gitcoin, look up Algorand and Algorand Foundation. There's one out there for 150,000 algos for a game development. That's a lot of money. Algo's going for around $2, so that's almost 300 grand. So take a look at Gitcoin. It's been a pleasure. A real pleasure. You have no idea how much of a pleasure it's been to do a live presentation to you all here. And I hope you all enjoyed the conference. And how about giving a round of applause for all the organizers?